Alrighty, so today we are going to do topic 3 in our notes packet, but before we do that, I thought I would give you the answer key to your homework from last night just to make sure that you are ready to move on. So here's the answer key. I will scroll, so you may want to pause and check this part. Here's the next set. Actually, I think I can maybe get all of it on here. There we go. So again, pause and check. I will say number 6 was a little bit of a throwback question because there wasn't adding or subtracting or any like distributing you had to do. So this was just a laws of exponents problems, making sure you remembered how to multiply whole numbers to whole numbers, x's with x's, y's with y's, etc. So yeah, save any questions and let me know whenever I get back and I will do my best to answer them. Alrighty, so what we're going to conquer today is whenever we have a binomial times a binomial. Yesterday all we had were monomials, right? So today we're going to expand it a little bit, and we're going to start again with algebra tiles. So I'm going to draw my algebra tile mat, which looks like this. I'm going to put one of my factors, which again, a factor is a part of a multiplication problem, along the top, and the other factor along the bottom. So I'm going to put x minus 1 along this side. It really doesn't matter. Okay, I'm going to shade it in to make it the negative. And then x plus 3 up here. Okay. So I mentioned last time that we're going to make kind of like the little roads in between the buildings. So I've got a line here, a line here, a line here. And I'm going to go across as well. And now I can see what I need to fill in. So I've got a big old x squared right here. Got a bar there for x, another one, another one. Now here's something we didn't talk about yesterday. When I start filling in this row, I am going to kind of think of like battleship. I am multiplying, see if I can use a cursor here. I am multiplying how do I point? I want like a laser pointer that y'all could see. Ooh, maybe there's a laser pointer. No, okay. Regardless, I am using this column right here, and I'm multiplying it with this row right here. So again, I don't know, hopefully you can imagine this. We're putting those two things together. So we've got one x here being multiplied with a negative 1 here. That's going to create a negative x, okay, because it's a negative times a positive. Now this box right here is, again, going up from here, is going to be one single box that's positive going across one single negative. Well, again, a positive times a negative is a negative. Same with this one, same with this one. These things above, like this, is not negative because if I look across over here, I was multiplying a positive times a positive, so it's still a positive. Hopefully that made sense. That would have been a lot easier to teach not in a video. But for me to summarize that, we have one big x squared, and then we have 1, 2, 3 positive x's, 1 negative x, and then minus 3. Which I don't really want to leave it that way. I'd actually like to combine these two. So I've got x squared plus 2x minus 3, and that would be our final answer here. Okay, so let's see how this works out algebraically. This is kind of the weirder part. I'm going to rewrite my problem. X minus 1 times x plus 3. And I'm still going to distribute, just like we did yesterday. However, I'm kind of going to double distribute. I'm going to distribute everything. So this x, let's just pretend it's by itself. I'm going to multiply it times the x and times the 3. So what is x times x? Well, x squared. What is x times the 3? Well, 3x. Okay, and it's all positive. But now I also have to distribute this negative 1. So negative 1 times x is negative x. Negative 1 times 3 is negative 3. Now I've really distributed everything. I did the first term with the third one, the first with the last, the second with the first, and the second with the last. I've kind of done everything. So at this point, I just need to combine these inner pieces because they're like terms. And I've got x squared plus 2x minus 3, which is the same exact thing I got whenever I used the model. Okay, so it's very similar to yesterday. You're just doing like double distribution is kind of what I refer to it as. Sometimes you have triple distribution and quadruple distribution. For the most part, it's just double. So similar to yesterday, you'll probably catch on pretty quick and can just use this video as a way to check yourself. Please do not just speed through this whole thing, finish really quickly, and never look to see if you did things right or wrong. So first problem, x times x, x squared. X times negative 5, negative 5x. Negative 3 times x, negative 3x. Negative 3 times negative 5, positive 15. This is a good example of when a lot of y'all might rush and forget something. There's a lot of negatives in that problem, so you want to make sure you're thinking about negative times a negative is a positive, etc., etc. So again, I'm going to combine these two. So x squared minus 8x plus 15 would be my final answer. Okay? I'm going to go over here. I don't know why it says number 4. I don't know what happened to number 3, but whatever. So again, starting with the first term. 3x times x is 3x squared. 3x times positive 4 is 12x. Negative 2 times x is negative 2x. Negative 2 times 4, negative 8. Combine the like terms that always happen to be in the middle. 3x squared plus 10x minus 8. Okay? Number 5 is actually very similar to the ones we just did, even though it doesn't look like it. Remember that 2 minus y squared, means 2 minus y times 2 minus y. Okay? If I was in front of you right now, I would question you, and I would say, okay, could I just distribute my square here? And I'm guessing, I don't know, but I'm guessing some of y'all would say yes. So let's test it out and see if we can do that. But let's do it the long way. 2 times 2 is 4. 2 times negative y is negative 2y. I'm going to do my negative y. Negative y times 2 is again negative 2y. Negative y times negative y is positive y squared. So if I combine all that, I'm going to have 4 minus 4y plus y squared. Well, would I have gotten that same answer if I just distributed my exponent up here? The answer is no, right? I would have just had 4 minus y squared. So we have this extra term in the middle that we may not have gotten before. So when you have a subtraction sign in the middle, you cannot distribute this exponent. It doesn't work that way, okay? It only works that way if it looks like this, because that is a monomial, and you can distribute the 2 to both of those pieces. But whenever you have multiple terms inside the parentheses, you can't distribute the exponent. So you really need to write it out twice, like we did here, and work it out the long way. Okay? All right, number 6, 2x times x, 2x squared. 2x times negative y would be negative 2xy. 3y times x, 3xy. 3y times negative y, negative 3y squared. So again, I'm going to combine my like terms. So 2x squared plus xy, because we only have 1, minus 3y squared. Okay? Alrighty. So number 7 is an example of just having more terms, right? We're doing a binomial times a trinomial. So you could call it double distribution still if you wanted to, but really, like this 3x, I'm going to distribute it to 3 separate things, right? And then my negative 5 is going to get distributed to those 3 separate things. So I don't even know if double distribution is the right word, but you're still going to have to distribute it a bunch of times. So if you want to maybe pause right now and try this one on your own, that would be a good one to do if you haven't already tried something on your own, because it's exactly the same. You just have more of them, which means you have more combining like terms to do at the end. But go ahead and pause if you want. I'm going to go ahead and work it out and explain it, but this would be a good time to try it on your own. Okay, so 3x times 2x squared would be 6x to the third. 3x times 4x is 12x squared. 3x times negative 3 is negative 9x. I'm going to start with my negative 5. Negative 5 times 2x squared is negative 10x squared. Negative 5 times positive 4x is negative 20x. Negative 5 times negative 3 is positive 15. Okay? So I need to combine like terms. And these are a little bit more broken apart than they used to be, right? There's only 1x cubed, okay? But then I see 12x squared, and then over here, negative 10x squared. So that's 2x squared. Then I see negative 9x, negative 20x, that's negative 29x. And then I just have this little 15 all by itself. That would be our final answer for that one. I don't have anybody here checking to make sure I'm not making mistakes, so hopefully I'm not. All right, number 8, a square tabletop has side lengths of 4x minus 6. Before I even move on, I'm going to draw a square. Okay, side lengths of 4x minus 6. Because it's a square, I know that they are all 4x minus 6, right? And because we might have to do perimeter, you might as well and label all of them. So it says write a polynomial that represents the area, okay? Well, I know that the area of a square, we could just do this, right? But just in case I don't get confused and try to separate or distribute the square, I'm still going to rewrite it as 4x minus 6 times 4x minus 6 and simplify it that way, just in case. So I'm going to, again, distribute all these pieces. Feel free to pause at any time if you want to wait and see if you get the answer on your own. So I've got 16x squared minus 24x. Then again, I happen to get minus 24x plus 36. Combine these middle two, so 16x squared minus 48x plus 36. There's my answer. Alrighty, number 9. And then 10, I think we're done. Yeah, all right. So the diagram shows the dimensions of a sandbox. Write a polynomial that represents the area of the wooden frame. So that's the shaded part. So very similar to the one we did yesterday, we're going to look at the shaded region by subtracting the total minus the white region, the part that's not shaded. So the big rectangle is going to be 3x plus 5 times 3x minus 4. And I'm going to subtract x times x plus 1. Okay, so I'm going to simplify each of these individually. So this side, 3x times 3x is 9x squared. 3x times negative 4 is negative 12x. 15x, negative 20. I'm going to go ahead and simplify this again. Okay, so that's my first piece. That's the area of the first piece. I'm going to subtract whatever I get over here. This one's just a quick little thing from yesterday. You get x squared plus x. But remember, I talked about if I'm wanting to subtract that entire area, I need to make sure that I'm using that distribution of the negative, okay? Because this is really separate things all the way across. So let me distribute my negative. Negative there, negative there. So when I start combining like terms, I've got a 9x squared and a negative x squared. So that makes 8x squared. I've got a 3x and a negative x here because I distribute this negative, right? So I've got 2x. And then negative 20 is just all on its own. Alrighty. There's that. Last problem says find the volume. Now I know that volume is length times width times height, so I need to multiply all 3 of these together, right? Well, I can do this a few different ways, but what I would probably like to do is take care of this x right off the bat, right? So let's just do x times x plus 3. So let's just do kind of like the length and the width, if you will, and then we'll deal with the other dimension here in a second. So that's going to be x squared plus 3x. So again, with length times width times height, it's like I just took care of the L times the W, and now I'm going to deal with the H. Okay, so there's the first part. Then I'm going to add on to that the piece I haven't used, the 2x squared minus 3. So I've done length times width already. Now I'm going to multiply it by that last number, the height. So again, we double distribute here. So I've got 2x to the 4th minus 3x squared plus 6x to the 3rd minus 9x. So I like to put things in standard form so that I have them in the descending order of the exponents. So I'm going to 2x to the 4th first, and move my x to the 3rd next, my x squared next, and then just my normal x at the end, because that's x to the 1. And there's your final answer. Alrighty, I feel like I went really fast through that, but hopefully you got it. I went kind of fast because I'm picturing y'all here with me, and I feel like you would totally get it. So if you do have any questions, let me know. The sub should have your homework that you can practice on. And again, if you have questions, feel free to send me an email or a mind text, or come to tutoring on Friday morning or Friday after school. I'm available. Alrighty.